COVID, whether we're talking about acute, it's one thing. Whether we're talking about chronic COVID or PAX, it's another thing. So I think this is a golden opportunity. So for me, I'll introduce myself. So basically, I have gone full circle, which the whole reason for putting this here is because I wanted you to know that I'm not a linear thinker. I absolutely do not think in algorithms. I don't think linearly. I think in circles. I don't know how I think, but in multiple dimensions. And it started because I was in physiology and also was a member of the US national rowing team. So as an elite level athlete and as a physiology and nutrition major at Boston University, I was really fired up about health and how to keep people healthy. I also came from a low SES background and everybody was unhealthy. My dad died in his 40s when I made the national team out in Lake Placid. He died and he didn't get to see me race or anything like that. And he died of a heart attack, sudden cardiac death while I was over in Europe racing. So I was very sad about that. And I wanted to help people, but I wanted to help them and be preventative. I also worked in the Army, for the Army and at the Army Research Institute of Environmental Medicine, doing research on, horrible conditions, whether it's cold or, body bags in the heat, body bags in the cold, different types of masks for chemical warfare, etc. So that was kind of fun to kind of see all of that dimension. Then I taught high school science, math, and wellness, and college at Wellesley College. And basically, while I did that, my goal was to coach the national rowing team, which I did in the early 90s. Went to med school. I did a pathology internship, mostly because I had 3 kids when I graduated from med school, all under the age of 15 months. So I said, let me do something easy and do pathology, which actually was not easy at all. But it was a good way to not have anybody need you immediately. So I spent a lot of time in the morgue, probably 6 months of my internship in the morgue, and then 6 months connected to the OR. And then I did internal medicine for 3 years. And then I went backwards again.
You guys gonna watch crazy doctor stuff now?
Let me just mute people. Can somebody mute up? Can everybody mute? Like I get distracted. But I went backwards from the morgue to palliative care, geriatrics, internal medicine as a primary care doctor. And then since about 2005, I've been doing regenerative medicine and really thinking lots about what I'm doing there. Let's see, next. So from COVID-19 and PAX, long haul, what can we learn? Well, I think we can learn a lot. It's still affecting communities globally. There are so many variants, and it makes no sense for me to be prophylactically treating people with vaccines when we have multiple variants and we don't even know how those vaccines are going to function in that row. There are so many multi-system health issues that are emerging, either as PAX long haul or as people who have had COVID and been exposed to COVID with their disease processes, whether it's IBD or any other process. If they've had PAX or long haul, then it's more difficult to treat their symptoms. So it requires a unique approach to treatment beyond simply managing symptoms like brain fog, et cetera. We have to be thinking a lot more holistically and integratively. So I like to think about the immune system in immunopathology because we think of pathology in every other system and we think about how we optimize those systems. But when we think about an immune system, we have to wonder, how are we going to optimize it? Just like how are we going to optimize our performance, regardless of what sport we want to do, tennis, rowing, hockey, football, whatever you want to do, you've got to figure out how are we going to optimize health. And how are you going to optimize the immune system so that the brain, when it gets hit in those hockey games or football games, the inflammatory picture in the brain doesn't become a chronic long-term situation? How are we going to minimize immunopathology once somebody has it? And what biomarkers are we going to use to assess immune health and immunopathology? And here are some lessons from the past. I mean, back in the 1980s, when the chronic fatigue syndrome was first coined by Cheney and Lapp, this was basically due to what they called the bad flu season back in Nevada. And what they learned, Cheney and Lapp did and wrote about in the mid-1980s, was that they understood that it was an alteration in immune system function and that there was a state of chronic inflammation. So that was the beginning. And even still at that point in time, it was really probably for another 15 years. We know it takes 15 years for doctors to catch up in the conventional world. So it was probably for another 15 years that we called that psychogenic. Well, later in the 1990s, Mays and Paul wrote about chronic fatigue syndrome, and they then associate it with not only immune system dysfunction and sustained tissue specific inflammation, they also said that there are mitochondrial issues, and they're functional. They come and they go. The immune system is dysfunctioning, but there's also oxidative stress, and there are complex multi-organ symptoms and deficiencies or imbalances. Then in the mid-1990s, there was Gulf War syndrome, the nerve agents that were used in the Gulf War. And basically that resulted in chronic fatigue, myalgias, and deficits within the central nervous system. And that too, when it was written about, was associated with mitochondrial defects with lasting deleterious impact on immune function. And, it really boggles my mind that here we are in 2020, 2021, and with these few symptoms or syndromes appearing, how many years ago, 35 years ago, even more, we're still looking at long haul post-COVID-19 and acute COVID-19 and thinking that it's brand new, that, how are these people getting sick? It boggles my mind that we're wondering how people are getting sick, because when and who looks at the immune system, the identity of an individual, and determines what we have to do at a baseline when they visit us in our office. How are we going to get them better? How are we going to optimize it? And that's really the charge that I think we have to do. We have to learn that how are we going to review with our patients at baseline, and probably many of you are, what is their immune situation? What kind of pathology do they have from the immune system perspective? And what are we going to do about it? And it is absolutely likely that long haul post-COVID-19 or PAX basically shares some immune mechanisms with Gulf War syndrome and with chronic fatigue syndrome. So which ones? We have to understand. I'm sure for some people it's mitochondriopathy, for some people it's more oxidative stress, for some people it's more immune dysfunction, but we've got to understand for each individual, what is it that we're going to treat and how are we going to help them? The best way to help somebody is to have known their baseline and then to optimize what you find after they're, after they become sick or before they come sick so they don't get sick. So immunosenescence, we talk about aging of our skin cells, aging of our hair. Everybody knows about how to do hair, and I can make hair grow back as well. But the question is, can I really look inside at biomarkers and understand what kind of data I need in order to address an aging immune system? Whatever your immune system is before you get COVID-19 or get exposed to it, the underlying baseline status of immune system, because it's involved in all disease processes, should be known before getting COVID-19 infection, because that will damage immune cells as well, and it will accelerate immunosenescence or the aging of immune cells. When we have aged immune cells, it's just like having aged skin cells. They have to be slothed, they have to be gotten rid of. We spend a lot of time, exfoliating our face and doing all of these kinds of things for, exfoliation of any system. We've got to be thinking of the immune system as well. And if the immune system status is not known, and we start to boost the immune system non-specifically, that could actually result in adverse outcomes for people with pre-existing altered immune system function. And I think that's really important to consider, because we just start throwing things in an untargeted way, and we've got to determine prior to throwing these things, how are we going to get a targeted approach, not a hit or miss approach? So when we think of any immune system disease, regardless whether it's autoimmune, autoinflammatory, cancer, malignancy, infection, we've got to understand what's going on and what ingredients are necessary. And this is a slide from Dr. Alessio Fasano, who is the chair of mucosal immunity, the mucosal immune system at the Mass General Hospital. And he is the father of looking at, all of the gut health, zonulin, occludins. He works on autism, but essentially each of these has their own component. So there's part genome, which is very small. There's epigenome, and how, external environmental factors are affecting the genome, including food, including radiation, including medications, etc. There's gut permeability. So these are the things that we have to be measuring in our patients. To the extent that we can know the genome, the methylation factors, whether anybody has a factor 5 or a factor 2 or any of those things prior to getting an infection, we have to know that. We have to know whether they're, they've got HLA, DQ2, DQ8, whatever their HLA patterns is. It's pretty much easy to get those tests and they're cost effective. We should also know about their exposures, and we'll talk a little bit about that. Their immune response to any of these things is going to be independent and variable over time because they're going to have different exposures. Their genome is going to be responding phenotypically differently, and their gut permeability could become worse or better over time. And the microbiome will have a very big impact on the body and producing somebody who is well balanced and well optimized. So this is a photo from the 1960s with Dr. Goldstein here, a young doc at that time. He's now in his 80s. And this is Dr. White, his mentor. And so basically what they did so many years ago, 65 years ago, was they understood the thymus. And they understood that the thymus gland released these pre-T cells, the immune cells, stem cells. So the thymus gland will release some thymic factors like thymosin alpha-1, thymosin beta-4, TB500, etc. And the goal is for the thymus gland to release these stem cells that can go through mitophagy and create T cells, a variety of T cells, cytotoxic, CD8, CD4, T helper cells, T regulatory cells, etc. And that when there is no interference, we get immune system balance, normal T and B cell amounts and functions, and we have immunity and we are protected from disease. When this is back in the 60s, remember, when there are genetics, they didn't know epigenetics, or viral damages, or radiation, or chemical, or other, this was as simple as it got, and there was an interference in this release from the thymus gland and these stem cells to divide into healthy T cells. Basically, we end up with an immune imbalance, and this is the basis for all diseases. It's the basis for autoimmune disease. It's the basis for autoinflammatory diseases like cardiac. It's the basis for cancer. It's the basis for infectious disease. And we'll see more of this in a little bit. So here we know that we can do young blood transfusions to older people. So when we're looking here, right in the middle, we're looking here at the thymus gland, which is so critical. And we're looking here at the bone marrow. And both of these will release both hematopoietic stem cells for T cell line and for myeloid lines and for lymphoid lines. And in the young, we can see there's certain types of balance. And as we age, and old could be someone with lupus at age 18 who's not doing well. Someone with type 1 diabetes who's very sick, who's not doing well. And so we all age at different rates. And so the reality is that these differences in the balances between the myeloid and the lymphoid baseline, the T cell lines, basically will be variable from whatever age to whatever age. But ideally, we want to be pulling back and making healthy balances, both from the thymus gland, the bone marrow, and all of the hematopoietic stem cells and their progenitors and the way that they divide, and then what will be available in the periphery, in the lymphocyte pool, that it will be readily available to circulate and to help us be well, be immune balanced, and also that it will be efficiently replenished. But here we have in somebody who's older, and it doesn't really matter the age, because I remember being in geriatrics and I remember being in, transitional units, and I had plenty of people who were between 20 and 40, that were at end of life. And so these people have few cells that are generated in order to go and efficiently replenish our peripheral lymphocyte pool. And that's really important to understand. Here's another graph that shows it again. So this is back from the 70s, mid 70s, the thymus gland, the bone marrow, basically releasing from both sides pre-lymphoid stem cells, hematopoietic stem cells. When there's balance, there's nothing interfering, and T cells get expressed in the right balance, CD4, CD8, helper T cells, suppressor T cells, regulatory T cells, you name it. And then they enhance the production of humoral immunity, cell-mediated immunity, humoral immunity, and there's cooperation between these different T and B cells, between T cells, between B cells, that basically create good balance. And in this situation, you don't get diseases. But regardless of the age, this could be at a young age because of exposures, or it could be at a middle age or older age, the exposures are going to shift the way the immune system differentiates. So we're going to have T cell regulation deficiencies. We're going to have a decrease in suppressor T cells. We're going to have an increase in null cells that are coming out of the thymus, decrease in T helper cells, or whatever. It's going to be different balances in anybody. It's going to lead to malignancy. It's going to lead to autoimmunity, and it's also going to lead to autoinflammatory diseases. So immunopathology is a really big deal, and we really have to understand, what those factors are here that are going to change and shift the immune balance. We certainly know that nutrition is essential for the immune system to function well and to protect us from illness. And one of the really important things to understand is this healthy microenvironment, the milieu. And the milieu is not only the milieu of what's flowing in the bloodstream, but even more importantly, stem cells to differentiate, it's going to be about the milieu in the extracellular matrix, because that's going to be where we're going to find these stem cells that can differentiate as well, that are just sitting there wondering when their time is. But if the ECM, the extracellular matrix, is not healthy, then we're not going to be able to help to, allow those stem cells to divide and to heal the tissue around it. So studies of COVID-19, our prototype disease, basically have indicated, obviously we know that comorbidities and aging are linked to changes in immune system function. It's no wonder that we don't go back and look at this to prevent these people from getting well, or to treat them when they get sick, not from getting well, from getting sick, but also to treat them when they do get sick to prevent them from getting PAX or other issues. So these issues are associated with increased cytokine storm. The type of immune system imbalance prior to exposure to COVID is really important. And the pre-existing balances in certain immune cells are really important factors to be considering. What does our CD4 count look like? What does our CD8 count look like? With COVID, it's mostly CD8. So we know that the CD8 counts go down initially, and we need to know that we can have a good natural killer CD8, CD57 ratio. So here's long haul, and basically with post-acute COVID syndrome, we know that those who are most at risk are people with aged immune cells. Back to that, back to that slide that showed young and old immune cells. So those over 50, people who have experienced a severe case of any disease before will be at higher risk, and people with underlying health conditions and comorbidities. Because remember, comorbidities, hypertension, blood sugar issues, whether they're autoimmune or autoinflammatory, are related to your immune system. The immune system was not able to protect the organ. So regardless of if it's MS and the organ is the central nervous system, or if it's type 2 diabetes and the organ is the pancreas, the immune system is involved. So pre-existing activities in immune cells and balances is really important, and optimal nutrition. So we've got to be looking at these things. So here's a study in 2015 in Cell that basically looked at the influence of diet and lifestyle. And this is really promising because it looked at their influences on the immune system. And remember, that will be epigenetic. It won't change the gene. The gene is the gene, but it will change the function of the gene, which is the phenotype, not the genotype. So basically, there was a large collaborative study done between Karolinska, University of North Carolina, and Stanford. And together they demonstrated that there is considerable variation in immune system status and function among healthy populations. So when we go back and think about that slide that showed young blood, and old blood, that's a dynamic situation. And it's a dynamic situation based upon how we're addressing it. So whether we're getting enough sleep, whether we're eating the best food, whether we're moving, whether we're exercising, and all of those different things, but it's variable. And the way that they showed that this is mostly non-heritable, meaning is they studied twins. So they studied the identical twins, and they found that the differences in the variation were not genetically determined for the most part, that the differences in the variation in the immune system status and function were driven largely by lifestyle factors, the exposome that includes the diet and any of the other environmental factors to which the immune system has been exposed over the lifetime, because it's dynamic, remember. So these researchers looked at 204 different immune parameters. They looked at the different cell types, the different T cell types. They looked at all the different immune system types, and they looked at the cytokine responses from those immune cells. And they looked at proteins within the serum that are derived from the immune system. So all the cytokines, the inflammatory, the anti-inflammatory, etc. And what they showed was that 77% of these parameters were determined predominantly by, and 58% almost completely by, non-heritable factors. And remember, these factors are variable at different ages and at different times, because it's about the understanding of the exposome, the cumulative influence of environmental exposures. So here's the abstract. And basically, they were looking to see if it was heritable, if the immune system function and health was mostly determined by heritable versus non-heritable, looking at twins, and twins between the age of 8 and 82. And basically, they saw that 77% of immune system function and cell types were dominated and almost completely determined by non-heritable, and that the cumulative influence of the environmental exposure was critically important. So we should know, I mean, Dr. Vajani and Dr. Bland and I mean, everybody is talking about the exposome and the immune and the cumulative influence of all of these environmental influences that lead to these differing immune identities. And when I think of my patients, I think, what's their immune identity? What is the identity of the immune system? Are they predominantly Th1? Are they predominantly Th2? What cytokines do I think are existing? Are they Th17? What's going on with respect to their immune system? What are the interleukins, et cetera? And anything I can measure in their system, I will measure, just to have a really good confidence that when I treat them, I have a really good sense of what's going on. Is it autoimmunity? Is it autoinflammatory? Is it malignancy-like? Do we have rogue cells? It's really important. We also have to think about the accumulation of immune cells that have had mutational injury within the DNA of the immune cells, and epigenetic changes as a result of the exposome, because that could increase the inflammatory state of the individual, of the patient, and thus the severity of COVID-19 disease. So this is an example of the exposome as a whole. So an external environment that we can control some of is we can control our diet. We can really think and eat foods that we grow, pick, and eat. The longer the shelf life of the food, shorter the health span of the patient. The shorter the shelf life of the foods that you grow, pick, and eat, the longer the lifespan of the patient. And there are multiple documentaries that suggest that, Game Changers, you name it. If we can manage stress, that's going to be fantastic, because we can manage the balance between sympathetic and parasympathetic tone. Too much sympathetic tone is not good. And in this, driven society that wants to stay up all night, I mean, I think one of the best things that COVID has done is cause us to calm down. Lack of movement. So, couch potatoes do not do well with respect to their exposome, pollution exposure, pesticide exposure, radiation exposure, medications we take. These are all things that are part of our exposome. I think some of the more important parts of our exposome, when you think of Dr. Yehuda Schoenfeld and what he writes about for several years, called the Asia syndrome, adjuvant, A is autoimmune, autoinflammatory syndrome, S, induced, I, by adjuvants. And these are a lot of adjuvants. Adjuvants are anything that comes into our body that's foreign to it. So mercury, lead, any of the arsenic, yada, yada. And gadolinium and thallium and things that we use to do radiological studies. And immune modulators. I mean, there's a lot of immune modulators and endocrine disruptors. Many of them are pesticides, but I think one of the bigger adjuvants that I can think of for our population is when we use Botox for headaches, when we use Botox for pain, when we use Botox for facial rejuvenation. That is a very significant endocrine disruptor, and it's a major adjuvant that really impairs immune function, because it sits in there forever and the immune system doesn't know what it is, and it circulates and circulates, and basically is a really big issue. And if you want to read on that, you can read by Dr. Howard ONeil and Schoenfeld on Asia syndrome. There are multiple studies on that are brilliant in the last 3 to 5 years. So addressing immunopathology means reducing the production rate of damaged cells. If we want to reduce the production rate of damaged cells, we've got to understand the exposome. And we've got to really look at these factors, and we've got to determine what can the patient do to remove adjuvants or foreign things to the body, or process industrialized food in order to help them get rid of these damaged immune cells. There are other ways that we could do it through macrophages. We have to eliminate immune cells, and we'll talk about this a little bit more, that carry messages from past exposures. So if you've had past exposure to HSV1, if you've had past exposure to Lyme, if you've had past exposure to mono, even if you don't remember having mono because your immune system handled it when you were 20 years old, but now at 40 years old, it's reactivating, that these past exposures have induced genetic mutations within the DNA of the immune cells that have been exposed to mono or Lyme or anything else. And we have to replace these old cells. We have to exfoliate them. We have to replace them with normal hematopoiesis from the bone marrow, maybe from the thymus. I'm not sure we're going to be able to do that, with new immune cells that are not imprinted with these prior memories. So that's really important. We do this for the face. We are so focused on what we can see, but I think as physicians, it's really imperative that, I mean, this is not going to be the last pandemic, and the vaccine and PACs and the long haulers are going to teach us a lot of lessons about how we should be doing this at baseline and in a preventative way. And I think that we can prevent our skin from aging well for the most part. So we want to prevent our immune system from aging poorly. I mean, we can prevent our skin from aging poorly by taking care of it. It's the same thing for our immune system. So this should not be foreign to anybody. So here's another, looking at the thymus and looking at one of the factors that gets secreted from the thymosin that we can also use to treat thymosin alpha-1. Here we have hematopoietic stem cells being released from the bone marrow. And we looked at these lines. There's a myeloid line and there's a lymphoid line. They come out from the bone marrow as stem cells. And then basically they become multipotent stem cells. They can become myeloid or they can become lymphoid. When they go down the myeloid progenitor cell line, basically we're going to get any variety of all of these. We measure monocytes. We measure erythrocytes, red blood cells. We measure macrophages. We can measure some, but through myeloperoxidase. We measure eosinophils. We measure basophils. We measure platelets, and we can see megakaryotes. All of these cells, we need to know, are they in balance? Are they in balance, not just the white blood cell, but if we take any of the numbers of the monocytes, the eosinophils, the basophils, the platelets, etc., but we have white blood cells that are low at 3.5 or 2.8. We're talking about low numbers of anything here from a low number. So it's all deficient. If we're talking about numbers that are 7 or 8 as a white blood cell number, and we're looking at the balances of these different types of cells coming out of the Department of Defense here, then basically we know that we've got good immunity. So we really have to look at the total white blood cell number, and then we have to look at what is the balance. But if the total white blood cell number is low, we know that we're not doing a really good job creating balanced immune cells. When they get on the lymphoid progenitor line, we definitely want them to become healthy amounts of T cells, natural killer cells. They're the first line of defense. They are part of the immediate innate immunity. So we need adequate natural killer cells, cytotoxic T cells, and all of these are going to play into, are we going to get appropriate antibodies or B lymphocytes, and are we going to get appropriate dendritic cells to help us do the fighting as well, because they're essentially the same as a macrophage. So I think it's really important to know this. And we know that, we've got to look at the balance of this. And we know that when we treat with monoclonal antibodies, when we treat COVID, in hospitalized patients with the monoclonal antibodies, we're using one line. We have ignored everything else here. And when we use a monoclonal antibody, remdesivir, or any of them to treat COVID, there's a dark side to all of that. And we still are understanding. If you go to Schoenfeld's conferences on immunology, the grandfather of immunology with the 12-pound textbook, you will hear about the dark side of using monoclonal antibodies that's still being deciphered over time. So I think it's really important. Sure, we're going to get somebody better, but it's the quick fix as opposed to really doing something that's really going to help this person. So we know that when there's immune dysregulation and when there's aging immune cells that we're not sloughing and removing, that we end up with an increase in Th2 relative to Th1. And that's the subset that we have. And when we have this imbalance of Th2 greater than Th1, because in a young person, like that initial slide that we saw, there's greater Th1 to Th2. As we age, greater Th2. And of course, if we don't pull back, if we don't understand the baseline, we're going to end up with many common chronic illnesses, like chronic fatigue syndrome when someone has any exposure to any bug, fibromyalgia, any autoimmune disease, MS. If we look at MS, if we look at type 1 diabetes, if we look at many of the autoimmune diseases, and we look at the studies in public health by MD MPHs, I think it's Ed Aiello, Aiello. He wrote in 2007, he's out of Harvard, he wrote in 2007 and 2010, several part series on autoimmune diseases, and the primary environmental consistent thing found is EBV virus. So the majority of people who have autoimmune diseases, particularly MS, I think there are about 7 of them. The primary finding that's consistent between all of them is EBV, whether or not they knew they had an infection. And usually it's the people who didn't know they had an infection who have a bigger risk of that. Oxidative stress. If people have a null GSTM1, GSTP, glutathione gene, or they have, a low functioning glutathione gene because they have a SNP with one variant, then they will also have a Th1 to Th2 shift. And these are reasons that we should understand the glutathione genes. And at the very least, we should be looking at homocysteine levels, B12 levels, folate levels, and glutathione levels and oxidative stress levels. So we should know as alpha lipoic acid, we can look at those levels, we can look at vitamin C, we can look at glutathione, because all of them they all regenerate each other. Hyperglycemia or any glucose problems, tobacco, alcohol, welcome to the pandemic, right? Many people are drinking more. How many people don't have dysbiosis? I mean, dysbiosis is very common. So understanding anybody has gas, it's possible they have dysbiosis. Anybody has GERD, it's possible they have SIBO, a bacterial overgrowth, microbiome overgrowth issue. But we've got to be looking at these, and these are all things that we can look at in biomarkers. When we are postmenopausal and we have estrogens that have shifted to E1, estrone, then we're predominantly Th2. When progesterone is present and E2 is present and testosterone are present in optimal amounts, we have predominantly Th1. So our hormones have a very significant effect on our immune system, very significant. Obviously, mood disorders also affect our immune system in bidirectional ways, as do other mineral deficiencies like magnesium. So in a chronic disease prevention and management clinic, we have to look at the exposome of our patient. We have to know their exposures from the beginning to now, which is birth to now. We have to know their diet and lifestyle factors. And I think we have to recognize, most importantly, because that's what we can do, that prior immune system health, prior to you seeing them, is an important factor that has to be monitored. We can't forget about the extracellular matrix. So all nutrients, the microenvironment, nutrient panels are very, very effective for understanding what has to be supplied in that internal milieu in order for the immune system to function better. And we can do this through a SpectraCell, looking at the white blood cells, through NutrIval, through ion tests. We can do it any way we want. And this is going to allow us to practice rejuvenation of the immune system, not immune support, not immune supplementation, but rejuvenation. So in May of 2020, during the pandemic, in the British Medical Journal, there's a group that wrote about nutrition prevention and health, nutrition immunity in COVID-19. And they suggested supporting the immune system. This is very non-specific, with daily dietary nutrients and, all of the ones we know that can be helpful for COVID-19, but we should certainly measure to make sure that we're targeting what an individual's problem is. But vitamin A and vitamin E, and vitamin A, as we know, is essential for vitamin D absorption. So A and D are no surprise because D is a primary immune system hormone. Vitamin C, which we don't make, and since we don't make vitamin C, we have to replace it. Since it's water soluble, it has to be replaced daily, regularly, even multiple times throughout the day. Zinc, omega-3, probiotics, etc. If there's been a previous immune injury secondary to any infection, Lyme, CBV, CMV, whatever, EBV, or any other adjuvant exposure, Botox, fillers, you name it, sorry about that, with sustained chronic immune dysfunction and this residual memory of these past infections, then the question that we have to ask is, are these really the dietary nutrients for that individual that are sufficient in the event that they experience additional immune injury as a consequence of COVID-19 infection? So I think it's really important to be thinking about these things because, we're trying to just support and basically do hit or miss and non-specific approaches. But COVID-19 infection does not happen in isolation. So if someone ends up in the hospital with moderate or severe COVID-19, or is more likely to get PAX or post-COVID, they are likely being injured with COVID, and they likely have had a previously injured immune system. And that is going to worsen the imbalanced immune state. And we're going to have the inflammasome, inflammaging, that is overactivated through NLRP3. We're going to have a heightened release and activation of inflammatory cytokines like IL-6, et cetera. And we are also going to have creation of bystander damage through these immune cells to these hematopoietic stem cells, these HSCs that are being released from the bone marrow, and you saw those images, and that are being, basically stored. And we're going to get mutational and epigenetic changes to these progenitor stem cells, immune cells, and they're not going to develop normally. We're going to have an imbalanced mitophagy of those cells. So we have to ask ourselves, why is there such a variation in immune system response when people get exposed to COVID? And this is a chart that basically looks at the exposome as a whole with different infections. So we'll focus here on severe infection. People who have had many exposures that haven't been addressed have affected their immune system over a long period of time, and they are cumulative, and they are going to have a severe infection. Alessio Fasano, people who have mucosal immunity issues, they have low IgA. They have low secretory IgA, they have low serum IgA, and they have leaky gut. They have occludin and zonulin antibodies, and they have LPS antibodies. They are going to have a compromised immune system, and they are going to become more severely infected. People who can't produce antibodies, IgG, IgA, IgM, IgG, you name it, they can't produce them rapidly, they are going to have severe infections. And people who have natural killer cells, the innate immunity, so the innate immune system, CD8 cells, natural killer cells, waiting right there inside the GI tract, inside that one cell layer, if they're compromised, if their T cells have been compromised, and if their white blood cell has been compromised, then they have an immune identity that is compromised, and they're going to end up with severe infection of the immune system. Because what we know is that post any viral infection, there is mutational injury in the genome of the immune cell. And this mutational injury resembles something called clonal hematopoiesis of indeterminate potential. So those hematopoietic stem cells that we talked about, those precursors back here, and those progenitor immune cells will basically suffer in their chip driver sequence long-term inflammatory phenotype, meaning that they will give off more inflammatory cytokines, more inflammatory interleukins, and that will be associated with mitochondrial dysfunction and immune system dysfunction. So this is really important to know. So the gene alterations from prior infections that may still be present but quiet, and COVID-19 infection impacts the complex and creates the complex symptom profile that we see. So it's really, really important. So again, coming back to these progenitor cells, these can be affected and mutated. This little chromosome can get mutated, and we can get a more inflammatory expression through, during mitophagy, not mitophagy, mitosis, as these are reproducing, as these cells are reproducing, and likewise down here, and that is the opposite of beneficial. So we have to identify the immune identity of a patient at baseline. Do they have previous exposures to HSV 1, 2, 3, shingles, 4, mono, 5, CMV, 6, Coxsackie, you name it. Mycoplasma, another big one. And then what are we going to do about that? We have to know that we've got to be then looking at their CD4, their CD8. We have to look closely at their monocyte absolute number. We have to look at their neutrophils. We have to look at many of the differential within the blood count. And we want to rejuvenate their immune system by selectively activating autophagy, which hopefully we'll be able to do with nanoparticles, and mitophagy, getting rid of and stopping the division of the immune cells that have that information in them that we don't want. So various lifestyle, dietary factors, and the exposome will all influence autophagy and mitophagy. So it's really important. So to be repetitive and to really drive this home, here's our innate rapid response the minute we get exposed to COVID-19. Here's our adaptive response that gets handed over from the innate. The innate keeps going, but the adaptive, the antibodies have to be made. And so we can see that natural killer cells are part of, both the adaptive and the innate immune system response. We have to know what that number is. We have to know the CD8, CD57. We have to understand that. What percentage are neutrophils, eosinophils, basophils, macrophages, monocytes? What's happening here? And so that's really important. We can't measure the dendritic cells at this point. And then we want to be measuring antibodies, understanding, do we have good IgG levels? Do we have good IgA levels, secretory and plasma? Do we have good IgG and IgM levels? And we can measure CD4 and CD8. And we know that HIV is a CD4 deficiency, and we know that acute COVID is a CD8 deficiency initially. So the considerations will be based on their immune identities, personalized lifestyle immunorejuvenation. We can do some prophylaxis if people are exposed, but knowing their immune identity will help us. It will help us to do acute COVID treatment using ivermectin, et cetera. And if there's anything else that we want to use, like thymosin alpha-1, and then whether we want to use other, really strong H1 blockers, et cetera. So we have to really restore a barren immune system function in order to do immunorejuvenation as opposed to immunosupport. So here's a sampling of some things, testing that you can do. We talked about the CBC with DIF and knowing all of these numbers. We talked about getting a sense of their Th1, Th2 balance, their natural killer cell function, CD4, CD8, all of the antibodies, secretory and plasma levels that we can get. IGF-1 is critically important. We have got to know whether they're in whether they have excessive IGF-1 because they are absolutely in an inflammatory state, or whether they have a low IGF-1 and we need to optimize it. Because if we use things like CJC, EPO, we can optimize IGF-1 because growth hormone releasing hormone and growth hormone releasing peptide all activate IGF-1 and the thymus gland. Doing endopath testing and pulse for pulse testing, pseudomotor testing, and you've all heard from Ken Beck, I assume, that's essential because that can help with knowing, are we actually rejuvenating the immune system and are we making progress? We can measure IL-6 in most labs without a cost. We can measure complement, C3, C4. We can see whether it's elevated already. We can measure VEGF, VEGF. We can measure TNF-alpha. So all of these biomarkers will help us discern where are we in terms of an immune identity. We also have to know the microbiota. So we should do a stool analysis. And oftentimes when we measure PCR of the stool and looking at the microbiome, basically what we find is that PCR is going to tell us the dead bugs that are there and the live bugs that are there. When we look at the culture, we can compare what we see that's actively growing, and we can go back to the PCR of the stool, and we can say, aha, if we have elevated PCR in Lactobacillus rhamnosus, and we have no lactobacillus growing, we know that that Lactobacillus rhamnosus is dead. And dead bugs can be worse than live bugs sometimes because they can be wreaking havoc because they're degrading. We really don't know what to do with them. So we have to understand dead bugs, live bugs. And when we do PCR culture through a nasal swab of a patient looking for COVID-19, we're looking at dead and live bugs. So we don't even know if that patient has a PCR positive and they never get infected, and we never see antibodies as footprint of the disease, whether they're IgM or IgG, we have to wonder if that PCR test that was positive measured all dead bugs, especially if the patient never gets infected. So I think that's an interesting dynamic. So these are other things that we can measure, because if we think of the body, it has multiple layers and barriers to prevent anything from getting to the brain. These astroglial, astrocytes, microglia, etc. This is in the brain. Here's our blood-brain barrier. Here's our blood barrier to the blood-brain. This is the extracellular matrix. And even more external is the gut barrier. So we have the gut barrier. If that gets disrupted, and we understand that there's intestinal permeability by seeing antibodies to occludin and zonulin and antibodies to LPS, we know we have a problem. We know that things are getting through. The cell junctions and the internal makeup of any of these cells basically is very similar. There's actin and tubulin and myofilaments that are in there. And basically, once the laces get disrupted, those laces are connected in here to these tubules, and they will get disrupted. So we can have intercellular leakage and damage, and we can get transcellular leakage and damage. So it's really important to understand that. So if we have a leaky gut, we will have a leaky endothelial or vascular junction, and we will have an ECM, extracellular matrix, a microenvironment that is not ideal. We will also get breakdown of the blood-brain barrier. And whenever we have blood-brain barrier, we have these microglial cells, and these are basically our macrophages and our inflammatory cells of the central nervous system. And we will see that they can release glutamate. We can measure glutamate. They can release QA, quinolinic acid. We can measure it. And more quinolinic acid is going to make more microglia. More glutamate is going to make more microglial cells. They can release arachidonic acid. They can release IL-6, TNF-alpha, all things we can measure. They can release lipid peroxides. We can measure those, peroxynitrate. They can affect mitochondrial function in a negative way, and we can measure that. And we can measure neurochemical excitotoxicity, which will affect the immune cells as well. We can measure synapsin. We can measure if there's synaptic dysfunction, and it doesn't have to cost a lot of money. So the reality is we can measure all of these things. And this slide is from Dr. Vajani at Cyrex, because he has a lot of different testing that can help us measure this. His testing is relatively expensive, so you can get some of these tests, and you can get many of them covered by insurance, like IL-6 and TNF-alpha and glutamate. And some of these things you can get in other ways, but it's really important that we know these, particularly if we think somebody's at risk for getting COVID-19. So when the immune system ages, there are causes and consequences of that, and reversing it, there'll be good benefit from that. So one of the simple things we can do is caloric restriction. And so we know that when we don't eat, particularly late at night, like after 7 or ideally after 7 or 6, that we have multiple beneficial effects on the immune system. And that includes a delay in the accumulation of these immunosenescent cells, particularly T cells. We stimulate thymopoiesis. The thymus gland will work better. There's a little bit of a conundrum here and a paradox where calorie restriction will reportedly reduce IGF-1, but that's in people who have elevated IGF-1, and which isn't actually effective anyway. And low levels of IgM we know are associated with thymic involution, but we can optimize that. When calorie restriction increases GH levels, which are thymopoietic, basically through IGF-1 independent pathways, we can basically, keep the thymus gland functioning, prevent it from infiltration with fatty cells, which happens to any injured tissue through this master regulator PPAR gamma. So it's very beneficial to do calorie restriction and to follow your IGF-1 as well to see what happens with that, because you can boost that if you need to. You can boost it with a gel, or you can boost it with a sub-Q injection. When we think about Supersize Me, pardon me, and we see that in 30 days, in a mere 30 days, that Supersize Me Morgan Spurlock went from day 1 on day 30 from 7%, an increase in 7% body fat, a weight gain of 25 pounds, right, just eating McDonald's, and a cholesterol markedly elevated. So, we know that our epigenetic lifestyle factors have a massive influence. We don't need to, look at that anymore. So restoration of the immune function is really important to think about the microenvironment. So this is another example. We will not be able to restore the immune function without restoring the microenvironment. Because if you try and you haven't thought about the extracellular matrix milieu, they will not be able to reach their potential. These cells will not be able to mature, and they will not function. So age, thymic, or any peripheral immune cell, the microenvironment is critically important to the degree of which we can regenerate that system. So we want this soil, all of this soil, not to be dirt. When you pick up dirt, it's dry, it falls through your hands, there are no minerals in it. When you pick up soil, it's more like oil. Soil, if you pick it up, it sticks to your hands and it feels oily. And you have to scrub and scrub and scrub to get soil off your hands. The soil will be the best microenvironment, right, that you can have. When we think of the worms in the soil, we're thinking about our microbiome. When we're thinking of the minerals in the soil, we're thinking about our nutrients. So we have to understand that this extracellular matrix is much like the soil. And in order for this little progenitor stem cell of an immune cell to grow and to produce something that's not a weed, then we need to have it bathing in the right microenvironment. Otherwise, if it's not a good microenvironment, it's going to become immunosenescent. If it does divide, it's going to have mitosis that's basically going to go rogue eventually. And we're going to want to have mitophagy and preventing that. We always want to be doing autophagy in this system so that we can take a seed and we can feed and the seed will grow. So feed this seed so it grows to be what we want it to be, a restored system, restored organs. And that's called Regenology. So the lifestyle factors for prevention and immune system autophagy or cleanup will be change the diet. I mean, get rid of processed foods, get rid of industrialized foods. Industrialized foods includes the meat products that are industrialized. So when cows aren't allowed to graze, when fish are grown in a fish farm, any of that, and you can see some of that in some of the documentaries like Game Changers, when any of that is industrialized, when it's not a natural grow, natural pick, natural eat, then basically, or it has a long shelf life, it's going to be a suspect that has to be gotten rid of. We want to increase the polyunsaturated fatty acids, the omega-3s, polyphenols, and flavonoids. And this is nuts, seeds, colorful vegetables, fruits, you name it, right? So we have a lot that we can eat. Fish, apply calorie restriction and fasting physiology, ideally at night, but however you can do it, and basically just not overfeeding. Promote a healthy microbiota, depending upon the baseline microbiota composition, using prebiotics and probiotics. Now, if somebody has constipation, I wouldn't start adding prebiotics, but if they have, you can add probiotics right away. But if they have constipation, you're going to want to, really kind of change the dirt to soil, because that's really one of the problems, to get the MMC, the migrating motor complex, to be working better so that people have healthier bowel movements. And that can be regenerated as well. So we want to, look at the extracellular matrix through all of our testing and personalize a healthy microenvironment. Here's a list of things that we can do to modulate the immune system and to increase Th1 relative to this inflammatory profile, Th2, and to restore homeostasis. We can lower these inflammatory cytokines and interleukins and boost natural killer cell function using peptides like alpha-1 and beta-4. We can do IVIG if the immunoglobulins are low, particularly IgG. If someone has a chronic immunodeficiency, we can look at the different type of sensitivities and allergens through IgE, IgA, and IgG, and we really do need to know, what antibodies are being produced to these different, foods and industrialized products. We need to look at what's going on with people in terms of mycoplasma, cytomegalovirus, EBV. Obviously, you'll know, it's likely that you'd know if they have HIV or if they're at risk for HIV, but all of these are really, really important because they're all related directly to the Th1, Th2 balance of the individual patient. Transfer factors are wonderful. I use them a lot with great effect, particularly if people have, spirochetes like Lyme or Lyme-like organisms, or if people have multiple viruses or bacteria, strep. Mushroom extracts are wonderful. High dose B12, Neupogen, GC-MAF, probiotics, silver. We need antioxidants, vitamin C, alpha lipoic acid, glutathione. And if we are loaded with heavy metals, after doing many other things, we would consider a chelation. So I think what's important in immunosupport versus rejuvenation, if we just do non-specific support, we're guessing. And I really think that we need to test, don't guess. And we can get basic labs, any stool testing here, any food and sensitivity testing, whether it's IgE, mast cell-like, or whether it's IgG or IgA, Nutrival, SpectraCell, the ion test, the ONe test, methylation panels, intestinal barrier assessments, neurochemical assessments, adrenal testing, and others. But those are all some of the tests that we can do. So in immune support, we basically do a general non-specific boosting, but we're doing that in an existing compromised immune system. And that's seriously problematic. That's not for us, that's for the conventional doctors. We could be amplifying pre-existing immune issues because we could be giving the cells that have those mutational injuries in the chip driver sequence, we could be giving them nutrients that they need, and we could be promoting their mitosis and division. We're not addressing a broken or dysfunctional immune system. We're basically just trying to buy time. So we also address the immune system as all alone, as, like it's in a vacuum and it doesn't impact anything else, and that nothing else impacts it, and it doesn't make sense. It's a quick fix versus a long-term focus on the health of your patients, the immune health of your patients, and their health span, not their lifespan, but their health span. How well is their life going to be? We can never predict their death, but we want them to be well as long as they can. That's the health span. And we're really focusing on the patient, and we're not really thinking of the exposome. And that's really important to address because it will just keep getting more and more cumulative. When we do rejuvenation, we understand the interconnectedness of it all, the interconnectedness of what you're exposed to, the planet, of your immunity, and how nature and our body is interconnected. When we do immune rejuvenation, we understand that all the systems work together, that the central nervous system, that the thyroid, that the neurochemical, that all of these systems work together. They are not, and none of them are in a vacuum. So we're taking an integrative approach to understanding and addressing what's causing the immune system dysfunction. And so we actually can address and do our best to pull back on a damaged immune system through mitophagy, and through an aging immune system, immunosenescence. This is autophagy. So we can do that. And we improve immune function from the molecular, because if our patients are better, the ecosystem will be better. And we want balance, but most important, we want resilience. So we want our patient to get, if they get COVID, to have a strong immune system, to get ivermectin and whatever else you're going to give them, be it methylene blue, be it thymosin alpha-1, be it Pepcid or any other H1. We want them to be able to recover robustly and be very, very resilient. So I've written a book on COVID, and that's how I have learned so much about COVID. This is Yehuda Schoenfeld. He wrote the foreword to the book. He is a wonderful grandfather of autoimmunity. I would look him up, and I would look up his Asia syndrome. These are just some, little charts that are in the book that basically give people hyperlinks to references showing, the non-specific immune support agents that they could use. Here are more: quercetin, astragalus, melatonin. But basically, if you have no other option, and if a patient isn't seeing a doctor, my book was for direct to consumer, to go to their doctor, to get their doctor to understand that we want a healthy, a salutary environment with robust secretion and rapid secretion of B cells, antibodies. We want a robust secretion of T cells that are CD8 positive and CD28 positive. We do not want them to be CD28 negative because we have a skewed repertoire and they don't really work as well. So this is our innate immediate immunity that we want to be able to respond immediately to any bug, not just COVID. Same thing with CD4 cells. Every bug will have their, CD8, CD4 cells that are going to be the first responder. And so we want a good balance in all of these. But basically, when we have an inflammatory environment or immune dysregulation, we have antibodies that do not have the best affinity to cells that they need to respond to. We have CD8, CD28 negative cells, and it's a skewed representation. And here we have CD4 cells that differentiate into inflammatory components like Th17. And we want to pull back and begin to restore this balance for a salutary environment within the immune system. So you all know the different treatments for acute COVID-19. I don't need to go over that. You all know some non-specific supplements that can be used, as was cited in many of the papers. But most importantly, know the exposome of the patient, remove the exposures. Know your patient's antioxidant needs, vitamin C, glutathione. How bad is the number? Homocysteine, B12. Do you need to fix the high homocysteine with glutathione? Or do you need to fix it with B12, methylfolate, magnesium? How do you need to fix it? You need to target it by knowing the numbers. You need to look at the microbiome. You need to look at the microbiota, and you need to re-inoculate and provide prebiotics if necessary. And that's all determined through a stool study. And that will allow us to do autophagy and mitophagy of the immune system. Remember the exposome, remember these adjuvants, these foreign bodies that are exposed. So that's prevention and post-exposure prophylaxis that we all know. So this is a break where we can either go to, let's go to a case study. So let me go to a case study. So let me exit full screen. And then let me, exit full screen. I don't know, what is this gonna do? I don't want the speaker notes because they don't matter to me. I don't have any notes. So the next part was thymosin alpha. I'm gonna go quickly through this. I'm gonna go back to full screen. I'm gonna go quickly through a few things on thymosin alpha, which you probably all know about because Bill says he's taught you about that. Thymosin alpha, when we think about that immune profile and the thymosins and the bone marrow stem cells going to cause autoimmunity in cancer, thymosin alpha-1, as you probably know, has been used in acute infection, chronic infections, which are a little bit different, acute pancreatitis with infection, cancer, hepatic cellular carcinoma, liver cancer, non-small cell, not related to smoking sometimes, melanoma, malignant melanoma, and many others. It's amazing how much it's been used. And it's been used in more than probably, given since we've started using it here since probably 2015, there's probably been 25 million doses used in over 1 million individuals. It has a perfect safety profile, and they use it in Italy. It was first licensed and approved in 1993. China before that, Russia before that. So it's very widely used. It works on the TLR, the toll-like receptors, and basically is really wonderful. So it works on all of it modulates in an adaptogenic way, innate and adaptive immunity. So it works on all of these cells to optimize them, the innate immune cells, the adaptive immune cells, and it's quite remarkable. And this is from 2012, even though Dr. Goldstein and his preceptor basically have been working on this since the 50s. So it's really great. Oh, case 1. Okay, so here is a 15, I'll show you her testing. I'll pull up her testing in a minute, but I'm just going to discuss her case, and then I can show you the different tests that, now there are many ways to approach things. So this is a young woman, 15 years old. I know her mom and dad. Her mom is really well. Her dad has a bunch of autoimmune diseases in his family, including he has autoimmune Hashimoto's thyroiditis. So she was feeling really tired. She was mostly feeling exhausted. She goes to a small private school here with a track towards Harvard. And so she was definitely stressed at school, also during the pandemic with online learning. So she had some exhaustion with low mood. She also would periodically get some panic attacks. She had chronic headaches, very difficult time sleeping. And basically the key thing that her parents wanted was to rule out hypothyroidism. So we looked at a bunch of labs, her MPI, let's show you her lab. So let me exit here, exit. Let me see, bear with me, I apologize. And so now I'm gonna share a different screen with you, this screen. And I'm going to go to, hang on, I'm going to go to her labs. In no particular order because I don't know which are which, but I'll go here. And so here we did, this was the second, we did this after the first set of labs. Actually, let me go here first then. Okay, so here's her Cyrex, and she looks perfect in terms of foods that will react because they can be contaminated with gluten. She has no reactivity on this page. I was amazed. Wonderful.
I don't see your screen, Dr. Kathleen. I apologize, but we don't see the screen you're referring to, I don't think.
Okay, so let me stop share for a minute. Let me reshare. Looks like there are two. Okay, there's nothing for me. Let me go to share screen again, and I'll go here.
Oh, there we go. You got it.
Okay, thank you.
Sure.
Thank you for telling me. This happened the last time and I didn't remember that. All right, so these are just, she's in range with antibodies to everything that's gluten cross-reactive, that's gluten contaminated, and things that we replace gluten with when we get a gluten-free diet and other common antigenic foods. That was a surprise to me. I expected her to have some responses there. Let's go here. Nope, let's go here. Okay, so here is her wheat. So basically, she has MTG, microbial transglutaminase, MTG, IgG, 201, and an omega gliadin. So what this is telling me that there's probably a problem in her microbiome because she doesn't have transglutaminase, her own body's human transglutaminase that's creating an antibody, but she has a microbe that's living in her GI tract that is changing the gluten through the microbial transglutaminase into a toxic foreign product that's getting introduced into her extracellular matrix and bloodstream. So she has antibodies to this microbe. So we have to look at her gut as well. And we have to understand what does her microbiome look like, because maybe we can get rid of this opportunistic bug. I doubt it's a pathogen, this opportunistic bug that lives within her gut that basically is giving her a celiac-like picture. So for now, she doesn't eat a lot of gluten, but she should really stay gluten-free. The other reason that we would suggest that is because she has IgG antibodies to include zonulin that are mild, and we don't want those to increase to get over 1.6, where she's got open intercellular, she got massively leaky gut and increased intestinal permeability. And she also has a lot of acute IgM occludin zonulin antibodies. And the good news is this breakdown in her occludin zonulin in the intercellular space, the laces that hold the cells together, has not allowed for breakdown intracellular within the cell, so that her she's not allowing a lot of LPS product through, which is really, really important. Then we looked at, let me go this way. Do I also have her? Yeah, this one's going to be really important. So here's her, just some regular tests that are all covered by insurance. She has her period. That's probably likely from her period. But the rest of her white blood cell contribution looks pretty balanced. She doesn't have high monocytes. She doesn't have out of balance lymphocytes. So she's maybe slightly elevated, but looks pretty balanced. Her platelets look pretty good at 255. She's got a decent white blood cell count, no problem at all. She has a very, very low hypoglycemia. We asked her in her treatment plan to carry sugar around with her, and that seemed to alleviate her panic attacks and her anxiety. So that was effective for that. Her electrolytes all look fairly good. Her anion gap is slightly high at 16. She may have a little bit of metabolic acidosis, although her CO2 looks fine. Her creatinine and kidney function looks fine. Her EGFR, where is, they didn't do it because she's under 18. Her albumin globulin ratio, her 4.9 and 2.1, suggest that she has likely good stomach function and that she's, not aging. She's not one of the old people because she's actually has great albumin and great globulin. Her ALK phos is relatively low, and we definitely want to optimize her liver function, etc. She does not have inflammation of her LFTs. I don't know if I did a GGT on here. We'll see. Her homocysteine is not that elevated. Her iron is perfect. Her ferritin is fine, slightly low, but certainly not an acute phase reactant. Her CRP is very quiet as well at 0.1. She does not have antibodies to strep, so that's not something that I think her immune system has to battle. She has fine triglycerides. They could be a little bit lower, but they're okay. And now we look at some of the specialized proteins and look at anti-myelin against her glycoprotein IgM. That looks very, very good. Here we have her immunoglobulins. Her IgA is slightly on the low side. So this is in the serum. We'll look at her secretory IgM when we look at her gut function, but I would want to boost that. And we can boost that with vitamin C. Vitamin C in studies has been shown to boost secretory IgA if it's low. So and that's the work of Vijani. I learned that from Dr. Vijani in California. IgG and IgM, they're fine. Her thyroid. So let's look carefully at her thyroid, because when I did this for Halasa, he was convinced that there was a problem. I'm not really convinced there's a problem. Her T4, maybe it could be a little bit better, but her TSH is fine. Her central nervous system is getting the message that, she's got adequate T3. Her T4 is adequate. So at this point in time, she has no antibodies either. So she's holding her own. And generally, if we know Dr. Wilson from A4M, we know that before you get thyroid function, you have thyroid dysfunction, you're going to have adrenal dysfunction. So we definitely want to go back and look at her adrenals because her thyroids look fine. So that's not really part of the problem, but it certainly may become part of the problem. So in the bloodstream, she has a cortisol level of 8.6, even though she will go back, she was flatlined in her saliva. So for some reason, it's not traversing the extracellular matrix and doing a great job getting. And she has a DHEA sulfate of 159. It could be better in a 15-year-old. So, I think basically this may be a little bit subacute or chronic. She doesn't have any antibodies. Her complement C3 level is perfect. We should look at these numbers. Her C4 is perfect. She doesn't have rheumatoid factor, EBV. She has not had mono at this point in time. She does not have Lyme at this point in time. And often we see when it's just mono that this 41 kilodalton band will be reactive when it's only mono and not Lyme. And she doesn't have that reactive. She has no HSV2, which I didn't expect. They didn't do an HSV6. And here we look at mitochondrial and at beta-2 glycoprotein mitochondrial antibodies and cardiolipin to see if she has a clotting diathesis, and everything is normal. And oftentimes when I see that people get, really infected with any kind of bug, we have to be looking at their beta-2 glycoproteins, because if they have an abnormality or a new cardiolipin abnormality, that we have to be thinking about mitochondrial dysfunction. So these are in the inner membrane of the mitochondria. So really, really important. They didn't do Borrelia. Babesia is negative. Bartonella is negative. They didn't do Brucella or chlamydia, unfortunately. Chlamydia pneumonia. So chlamydia in the airway. She's had Coxsackie. These are not particularly elevated, but we know that this is something that her immune system still harbors. She does not have HSV5 or CMV. She does not have specific M2 antibodies, mitochondrial antibodies. She does have some mycoplasma IgG antibodies. So we've got to be thinking about what kind of immune cells have to be present and doing surveillance in order to keep Coxsackie mycoplasma away. So it's not substantial. She does not have substantial, chronic infections. Her scleroderma, her VEGF, her vascular endothelial growth factor looks perfect. And I think that's a really, really helpful number. She doesn't have a lot of IgE. She has a fine B12, but I would think that it should be closer to 1,000 in a 15-year-old woman. Her vitamin D level is low, which we think is pretty critically important, and she doesn't have HSV1 or toxo. So that was a big, robust, fully covered by insurance immune panel that we looked at. Oopsie. And this one we looked at, so we don't have to go there. And here's her, a nutrient evaluation. I chose to look, instead of looking in the white blood cells, I wanted to look more at antioxidant function for her. And I also want to look at mitochondrial function. And just here on page 1, this summary, when I see B2, B3, NAD, FAD, when I see these not working well, then I'm pretty convinced that she's going to have mitochondrial dysfunction or functional mitochondriopathy. It's going to come and go. When I see B6, I'm going to think of the interaction between an immune system and the neurochemical system, meaning the adrenal gland and the neurotransmitters, dopamine, noradrenaline, epinephrine, etc. So those are critically important given the symptomatology that this young woman presented with. So when we look, we can see she doesn't really need any immune boosters. She looks like she's going to have some microbiome issues, but her enzymes seem to be working well. And these are just cursory. I can measure these more directly by doing a stool. And then here we see vitamin C, which helps to regenerate other antioxidants there's a need for, and this will help her immunoglobulin A. So it's really important for the secretory immunoglobulin A. CoQ10 to help her functional mitochondriopathy. Glutathione, her level I think was 700. It might have been 900. I might get her mixed up, but we'll see it as we come up. And she clearly needs a lot of antioxidants in her diet. So we worked on changing her diet, and we worked on getting her some B vitamins as well. Her dad was taking a mitochondrial support, so she decided to take his mitochondrial support with NAD and FAD and magnesium, etc. She clearly needs a lot of essential fatty acids, omega-3, and likely DGLA omega-6. And she has some toxic inability to move toxins through the glutathione. And we'll look at the exposures, and she has a need for methylation. And she has a need for supporting the mitochondria specifically. So one of the things that's interesting in her is that she has a lot of lactic acid. And so it's likely that, her breathing better, concentrating on her breathing, deep inhalation, deep exhalation, etc., will be very effective for moving her lactic acid through this citric acid cycle, through the Krebs cycle. A little bit of zinc will go a long way. We have to manage her macronutrients and basically be sure that she can utilize her fats for energy, for long-term energy, And she does a good job. She's a little bit ketotic, slightly ketotic here. She's not breaking down her muscle or her organs or protein. And she basically needs to be using her carbohydrates better or reducing them at one meal. So she was told by someone to eat a high carb diet, but I think when we look at her adrenal dysfunction and adrenal fatigue, that's not going to benefit her. She needs to really start with some proteins, because when she gets stuck in this situation, she's going to feel really exhausted. And here we can see flow through the citric acid cycle, and then regenerating the energy is an issue. She'll have a functional mitochondriopathy, not a fixed mitochondriopathy, depending upon her heavy metal toxicity, which I don't think she has much, but I can't remember. And depending, because I looked at so many tests today, I can't remember this. It's been done a long time ago. But she needs a little bit of ferritin she could benefit from, and some glutathione. And we know she needs all of the B vitamins, the NAD, the FAD, the B2, to keep this all going. So here we see her dysbiosis. But this is just cursory. So we want to look more at the PCR and the culture in the stool. And here we see that she's got high noradrenaline. The question is it being used appropriately, or is it more inflammatory? She looks like she has pretty good dopamine. Looks like her serotonin's being, moved from serotonin to 5-HIAA. So we really need to look at these more specifically. Her kynureninic acid is fine. But if we look specifically at, is she hanging on to serotonin? Is she hanging on to adrenaline and epinephrine? And how much does she have? That's really important. And we'll look at that next. So here she is with a little bit of MTBE, which is basically a gasoline added methyl terp butyl ether that was put in gasoline to raise octane ratings. And that essentially comes from soil and groundwater. So it's going to be hard to treat. She has a need for magnesium. She's got an elevated threonine, which is a calming, soothing, inhibitory neurochemical, and it's probably elevated to try to calm her. She does eat a lot of chicken, and this may be from that. I'm not really sure, but it's negligible at best. I think we have to think about her methylation factors with the cystathionine and 3-methylhistidine. We don't have those results back yet, but those are pending. Here we look at her, we'll look at omega-3 and omega-6 on the next page, but we can tell that she needs a lot of omega-6s. We can tell that she's in the red for an anti-inflammatory DGLA, and we'll look at that in the next page. Her monounsaturated fats are fine, but here we really want to look at her polyunsaturated fats. This is really interesting because she had a relatively high carb when we looked at the pyruvate on the Krebs cycle, and here we're seeing a high percentage of saturated fats at 43%. And we know that this NutrIval is compared to rural North Carolina and people that don't have access to healthy foods. It's a lot cheaper for them to eat unhealthy foods. So we certainly don't want this, young woman to be, she has access to healthy food. She, goes to a $75,000 prep school, for goodness sake. And we also want her omega-3 index to be markedly better, and her AAEPA index. So here when we see, what is she consuming from an alpha-linoleic acid perspective, flax, walnuts, seeds, nuts and seeds, and in terms of greens, not much. So we have to improve that, because the only way really to get that is to eat it. Her EPA could be better, her anti-inflammatory, her DHA could be better. So we definitely need some fish oil. We definitely need some cold water salmon. And so that will benefit her greatly as well, as we try to heal that permeability and those occluding zonulin. Her grains and vegetable oils, not surprisingly, look perfect. Her gamma-linolenic acid looks perfect, but her DGLA is low. So really maybe using some evening primrose oil, borage oil, and bringing this up will get some to flow down to DGLA, because it's very anti-inflammatory. We definitely want to promote that. And she isn't even expressing a major inflammation because her body's just really quiet with adrenal fatigue as well, which we'll see in the next test. So here's her glutathione 780. That's way too low. We want that 3 times higher. So at least double. We want it to be at least 1,500, but if we could have it in the 2000s, that'd be even better. her CoQ10, even though it's normal in the red blood, in the serum, we definitely want to know what it is in the mitochondria, and there is a need for it. Her healthy nutrients, magnesium, potassium, critical. Potassium, absolutely critical. So I imagine that she's eating more processed foods, more industrialized foods, because, you know, that's when we usually see the potassium is quite low. And she doesn't have any real toxic elements to write home about, maybe a little bit of lead, but that we would deal with after we normalized all of the other tests. Hang on, let me go to her. This is her adrenal testing. And we saw that she had an elevated 5-HIAA. In the scheme of optimum, she's got an okay serotonin. So we're going to think about targeted amino acid therapy for treating, you know, these inhibitory and excitatory neurochemicals. But she's got, you know, an okay serotonin. So we'll try to enhance her serotonin production at night to make melatonin so she sleeps better every other night. But because her GABA is very low, her glutamate was very low as well, or glutamine, we will basically improve her GABA by adding the precursors for GABA from an amino acid perspective, like glutamine, and glutamate will make GABA if we have adequate B6. So we'll give her a supplement that can enhance the GABA production to get her up from less than 300 to a minimum of 600. So we'll do some GABA support every day. We'll start with in the morning and we'll add with at night. So we want to improve her inhibitory so she doesn't accelerate with her excitatory. We want to improve her inhibitory neurochemicals first with targeted amino acid therapy for a week or two. And I'll check in with her after a week and then we'll improve her excitatory. Particularly, she doesn't have adequate glutamate to make GABA. So we want to kind of understand how can we improve these things. And she's just over in her dopamine, and we saw her VMA and her HVMA metabolites. So we've got to put this together with that. But most importantly, when we look at her cortisol, she's pretty flatlined. So we definitely want to give her, you know, ashwagandha, rhodiola, and, you know, all of the herbal supports for her cortisol. So I think that, you know, let's go back to her. I'm going to stop my share and go back again to share. And we'll go to here. Oh, no, we'll go to here. And basically what we did for her over 2 visits was we got her, you know, we're not trying to win this in the first quarter of our time together. We're trying to have her as a long-term patient and gradually with phase 1, phase 2, phase 3 to add. And we don't want to overwhelm her or her mom, but we basically told them, okay, she doesn't have Hashimoto's. We want to prevent that. So we're going to boost her omegas. We're going to boost her immune system with IgG PRP. She didn't want to take a lot of pills, so we'll do spray and chewables. She has to get her vitamin D3 up, you know, take about 10,000 of that or 50,000 sub-Q once a week. Try salts to minimize her NI and GAP. That's potassium, which was low, magnesium, which was low, and calcium as a bicarb salt. So that's important. B5, B6 for whenever we get her glutamine and glutamate, that she can turn that into healthy neurochemicals like GABA. And then this was her dad's that he was taking for his mitochondrial function, his fatigue, low energy. So she tried it. And then she was just basically keeping snacks in her pocket for hypoglycemia. So we followed up on this protocol around March 7th. And basically her mom reported, wow, she's doing a lot better. So then we reviewed that adrenal fatigue test. So at this appointment, March 3rd, she was feeling much better, getting more sleep, no nausea, no panic attacks, no anxiety. Energy was a bit better, still fatigued though. And because of the level of stress at her private school, they were thinking of changing to a less stressful school. And we reviewed her adrenal fatigue test and basically gave her some GABA support, first in the morning, to be added in the PM once we started the morning, a little serotonin support through targeted amino acids, threonine, etc. And then adding adaptogens like ashwagandha, adrenal cortex, etc. And I'll follow up with her in 2 more weeks. So That's her case. I'm going to stop here and stop the share and open up for questions because it's been a long time. So did I
Thank you.
stop the share?
Thank you, Dr. Kathleen. Could you make one comment on the fact that the FDA has declared war on the thymosis and what we can do about it, if anything?
Well, like right now, what I understand is that the FDA is clearly shutting down tailor-made for thymosin alpha production. I don't know that they've gotten to other people. I know that there are groups that are basically accepting money. I forget the name of the group. It's the Clinical Peptide Society with Ed Lee, and I started that society with him, and also with
Dr. Lee and Dr. Martinez.
yeah, Luis. So yeah, basically they're trying to access. I'm talking with Dr. Goldstein, and they're talking with the FDA, and we're trying to see if we can make some headway on not stopping the production of that. It is an orphan drug here, so we should be able to use it. The problem is how do we get it? So other pharmacies still have it, you know, Wells and
I got a message from one called Create today saying they're not going to make any more.
Oh, wow. So they're trying to stop it before. There are a couple more, and I can send them to you, and you can try to get what you can through them.
Unless you do an IRB, possibly you do it under that, possibly with thymosin alpha, that will keep it going. Have you tried that with FDA? Is it okay?
Well, the goal is to go through Goldstein with that because he's done oodles and oodles of human-based studies on it. So the human-based studies are pretty significant. I mean, I'll pull them out, but the ones that he's done, you know, I have some notes on this, but you know, basically, of course, we don't, if it's preclinical and it's only been done, it's been studied in humans in, you know, multiple myeloma, malignant melanoma, non-small cell. I told you that, hepatocellular. It's been used in other cancers to enhance the chemotherapy. I mean, it's been studied. So it's pretty remarkable, all of the things that it's been studied in.
Dr. Kathleen, what they've done is they're looking at it from the point of view is what does the Drug Quality and Safety Act say about whether or not a compounding pharmacy can compound with this item. And so they're disputing that. That's what they're disputing. They're saying that you can't use it because it doesn't meet the standards you know, that they require in terms of, you know, it has to have a USP monograph, it has to be manufactured in an FDA inspected facility, and then it also it needs to be a component of an FDA approved product. And so what they're saying is because it was granted orphan drug status isn't sufficient, and that you would have to have orphan drug status plus some form of quote unquote approval. So that would be where the research that exists could be presented and then say, okay, this is what we're seeking here. Now, on whose behalf do you do that? I don't know, but you could do it on the public's behalf or something. But you know, that would be what they would probably require there.
Mm-hmm.
So they're looking for a manufacturer who makes the ingredients that is FDA approved, and I don't think we have any manufacturer.
Well, that's part,
FDA.
it's not that. No, it's just simply an FDA inspected facility, so it doesn't have to have approval. The issue is they're saying that a compounding pharmacy that chemical is not suitable or is not approved or does not meet the standards that the
So the raw material is not
right. It's the raw material bulk product issue, and they're saying it was not a component of an FDA approved product.
So all it takes is an FDA to register a manufacturer inspected to produce the raw material.
Not correct. That is completely incorrect. What it is somebody's going to have to present evidence to the FDA and prove that it works, much as the same manner as ivermectin, you know, which probably won't happen. So someone would have to basically invest in, you know, the studies to prove to the FDA that it works. They're saying, you know, regardless of, in other words, they don't review literature they're not paid to review, basically. They might look at it for reconnaissance purposes, but they don't place any credibility in it. And
But if it's FDA approved for melanoma, so it is
it's
an
not.
FDA
It's
approved drug.
not. There is
Not?
no FDA approved product in the U.S. that
Okay.
contains thymosin alpha-1. Now, it
Gotcha.
is approved for use elsewhere in the world. That is correct. You see, so but not in the EU to my study, and not in the US. But for example, as Dr. Kathleen pointed out, there are many places where you can purchase a quote unquote approved product manufactured by some large pharmaceutical company, I'm not sure which, that is out there. It has a brand name, it's marketed, all that jazz. So I guess that would be Russia, China, other places, but not in the US, unfortunately. And that is exactly the dispute.
So all it takes is to get those manufacturers produced in China, whatever, in China, and make it FDA approved.
That doesn't work that way. Someone has to pay for.
Yeah, pay. Yes, they do little studies and make
You
it
have to
approved.
file a new drug application.
Yes, that's what I'm talking about. Yes.
So this is used experimentally here, and it is also used in the Kresge Eye Institute. So
Yeah.
in Michigan, there's an eye institute, and it's been used extensively there. I know the docs, and I know the. I think I should just contact that doc and get to where they get it from, the pharmaceutical company that's a U.S. pharmaceutical company, and talk with them about getting it FDA approved.
Absolutely. So that's exactly what you would do. Yeah,
Mhm.
and as you suggest, the literature may already exist. So a study could be, fairly easily designed and duplicated that could use the extant literature to say, this is the direction we would go. The question is, what indication do you seek, and what treatment of what disease? They'll make you specify that. And so those are all.
Well, we know that thymosin alpha does polarize the immune system to Th1, so that will help for all patients with cancer and viral infection. That's the best application for thymosin alpha 1. Now, thymosin beta, it shifted to Treg and T4, so that's mean any disease that has too much of Th1 activities, it will be something good for it. Like autoimmune diseases, I will use thymosin beta, like multiple sclerosis. So that needs somebody. It's a big. It needs money, millions of dollars.
Right.
I need team of doctors.
It's very sad.
Active involved.
It's very
But
sad.
it's a good business. It's a good business for somebody who has money investment and they want to work with FDA and get something approved.
Right. And I think it's probably there's some complication I'm not aware of, or none of us are aware of, that makes it difficult for that to happen. Maybe it requires an extreme amount of money, or maybe there's some kind of scientific snag somewhere, but nobody's done it to the state. And so that's what the problem is. But I do agree that I don't think that should prevent patients from having access to it. If their physician.
Well, the other option, we have Bahamas Center right now for our team for Chronic Disease Prevention Management Center. And if you decide to have your patients to be going there for vacations and treatment, then that's a fast options. If you're kind of irritated with things, we have to come up with an options that's today, instead of talking about fantasy options like getting FDA approved. So what is the solutions? One of the solutions that we can do it for tomorrow is, if you have a problem doing it in your clinic, I have Bahamas Center ready to go. They are going to be part of Chronic Disease Prevention Management Center, and their clinic is open for US doctors to bring their patients and treat their patients there.
Great. Yeah. Well, let's not derail Dr. Kathleen's presentation. Certainly, when it would change the subject to the regulation.
Yeah. So I'm going to bring this up for Dr. Kathleen. Okay. And I think I text you about it. I think we need to make it. I mean, what you did, you show what we call the vitamin D deficiency syndrome. I believe all these patients, she's 15 years old. She's young. I don't think she has that problem of her metabolism like in age of 40, 50. So she's still young. All her enzymes is working. Everything is working. I think we need to look at the insult that she has, which is the vitamin D deficiency. I think the vitamin D deficiency start the whole problems, from a microbiome imbalance to mitochondrial dysfunction to her insomnia, because vitamin D involved in all of this. And if we fix just the vitamin D, all other metabolic errors will be fixed automatically along with that. But what you present, you show, this is what's very critical about your presentation. You show that how vitamin D deficiency led to all the symptoms and signs and metabolic errors, and it can be all collected together, all these abnormalities, and we can call this as vitamin D deficiency syndrome, which is none has been presented as that. I mean, they say all signs and symptoms, but I think we need to put it as a syndrome so that when we get this signs and symptoms, one of the signs is hair loss too. My wife, she had this problem with vitamin D deficiency. She had all the symptoms that you're talking about, hair loss, insomnia, fatigue, anxiety, depression, mood imbalance. And I think that's something we can put it and publish as a vitamin D deficiency syndrome. Will be the first time. None has been done it as a syndrome, because syndrome is a collection of signs and symptoms and lab. So that's something you may be consider. I know you want to do fast fix. So you did fix all the metabolic errors along with vitamin D. But if you go to countries who doesn't have the resources and money, you know, the treatment will be vitamin D, and all the metabolic errors with time will be fixed. That's what I can see. What do you think?
I think we're going to call it the HO syndrome. HO, Halassa O'Neill syndrome, the HO syndrome. Just kidding you. Yeah, no, I think you're right. I think you're right. I think you're wicked smart and you know what you're talking about. I agree with you. But I can't wait for vitamin D to fix it, because if that happens, I mean, if I waited, she wouldn't come back. So she really felt better in a matter of weeks with some of the things that she took. The goal was to keep her engaged, to keep her involved, and to have her coming back so that we could clearly, you know, make her better in the long run. So.
Oh, no, I know what you did. You just make her fast fix, which is great. I mean, I can see you have to look at the business aspect and all other things, and you want to have your patients feeling comfortable as soon as possible. And she has resources. So it will be, I think if I'm you, I'll do the same thing. But I'm talking about if I'm in Africa, I'm in Middle East where the resources is limited, we can just say, okay, just give them vitamin D. Hopefully with time it will fix. And we want to see that fix and how it's being fixed. So something you may consider in cases where they don't have the resources. And then we follow up all the metabolic errors and see if it's being changed or not after 3 months of supply.
I agree. I totally agree.
You mentioned repletion kind of immune injury, and I found that to be a fascinating subject. Like, what is a typical time frame for that type of treatment to work for a patient?
What repletion of?
Well, like you mentioned immune injury or the immune dysmodulation.
Yeah.
Like,
yeah.
How quickly can that be fixed?
Well, it depends on what you're using. If you use thymosin alpha-1, it's
Right.
going to be in an hour. You're going to feel it in an hour. So, and then if you use any of those, if we go back to the immunomodulatory therapies, depending upon which ones we use and how we use them together, people can feel better with a probiotic in a very short time. So you have to, you know, I think the benefit of being able to be a synthesizer of this information and take this information and synthesize it as opposed to using an algorithm. In the synthesis program, you're doing basically personalized medicine. So if you can't synthesize it and you want an algorithm, I do think that the metabolic code of Laval is a very good way to do that, because it will definitely help you prioritize and target. I feel like I don't know how I've developed that, but I've developed that over time. And so I can prioritize and target, because the whole goal is to get an initial response that's beneficial and then to continue to build. It depends on the age of the person. As Dr. Halassa says with this young 15-year-old woman, I mean, I think that she's going to recover pretty quickly. I've seen many high school students similar to her that recover by, you know, college sometimes and don't need anything in college. And if they don't recover by college, they recover by the time they're out of college. So when you see it later in life and they've already got other, you know, kind of, they have a medical history that nobody's really addressing from the perspective of regenerating, then you're going to have a longer time period. So it's going to take, I never tell people it's going to take 18 months. I say it's going to take 6 to 9 months, and then we're going to reassess.
It's really something that should be done in family practice then, really. almost.
Yeah,
Very,
for sure. Yeah, but it really won't be done because you know how that goes.
Yeah.
Anybody else have any questions I can help with? Yeah, thank you all for listening.
Thank you, Dr. Smith.
Let me just add something here. You said that she suffered from low sugar. Now, if the low sugar, if she has, does she has any compliance of loss of conscious, palpitation, coma? Because if this case is going to that direction, there's something called sporadic insulinoma. So we may need to consider high insulinoma in those patients, but I don't think she is in that case. But I think we need to watch her glucose, and if it's dropping and causing more drop problems, at least to check if there is insulinoma. Do you agree with me?
I measured her insulin level and it was fine. So I'm not really worried about an insulinoma because I measured the insulin level in everybody. If she didn't resolve with, basically with the cortisol dysfunction, I mean, cortisol will go up. When cortisol goes up, your blood sugar is going to go up. So where she has a low cortisol that can't be elevated presently, her blood sugar is not going to go up. And that's really the major thing there. So I did measure insulin. I did measure A1C. Her A1C was 5. Her insulin level was, something less than 15 with a blood sugar of 59. So she should have a 0 insulin with a blood sugar of 59. And the fact that her body didn't adapt to that situation is indicative of the cortisol issue and the basically flatline. And then also, of what's going on in the, with the imbalances within the excitatory neurochemicals, because noradrenaline, cortisol will increase your blood sugar, right? So the fact that she had, relatively low noradrenaline, adrenaline, and a low cortisol, it's going to be hard for her to increase her blood sugar on her own through gluconeogenesis, because those require those excitatory neurotransmitters, including cortisol. So I think that, that has to come back. But when she ate, and she couldn't do it through her own muscle, liver, etc., then basically she could increase her blood sugar. And that's why she no longer felt those panic attacks. And I can tell you in my own office, when people come in and they tell me they're having a panic attack, and they have them, if they have one in my office, I'll measure their blood sugar, and their blood sugars are well under 60. And then I can measure their insulin in my lab as well. And I can see what their insulin level is. So you can determine whether you're suspicious of an insulinoma. But then once you look at the cortisol and you look at the noradrenaline, you look at those issues, those help you as well. So she does have palpitations with her low blood sugars. The panic attack exists of, difficulty breathing, palpitations, sweating, feeling faint, lacking memory. So that was a pretty significant hypoglycemic episode.
Yeah, I agree with you. I'm just saying, if she went to the extreme, you may consider it, but you already exclude that, which is a great thing. I like it.
Yeah, you're talking about.
You did the work.
Yeah, no. Growing up in the Mass General of the Brigham, I know zebras. I mean, because I always got quizzed on zebras when they didn't really exist. But now I'm looking for the common thing. Of course I want to find the zebra, but I need to also know, what am I going to do? And that's what conventional medicine does. If I had to be at the Brigham or on the Mass General again, they would really want to be quizzing me on the zebra, and they'd say, don't worry about it. She's 15 years old. She's going to be fine. Right. And that, she doesn't feel fine. And she's going to have PTSD in the end if we don't do something to help her. She's really, really unable to get out of bed in the morning. So I think it's really important that we help these kids, and we help them to try to be well, because this is how we end up with autoimmunity. Particularly, I think she'd end up with autoimmunity. And I think that other people may end up with, which I see in kids, inflammatory diseases. And I think it's really a problem. You can have, I've had a kid that's young have a heart attack, So I think it's really important that we not look for the zebra, but that we look for, what are we going to do functionally to prevent them when they're exposed to something, whatever part of the exposome it is, that we can help them to be well.
I want to add a quick comment about solving the peptide conundrum. Some clinics have been doing this successfully. I don't know the legal aspect, but they're just telling their patients what they need. and they purchase directly from a lab in Canada. We found a lab that has really high quality products. They bring it in, and then the physician just charges for his service, for his fee, his medical fees.
I think that
So,
sounds great. Can you give us
Good
the,
option. It's a good option.
yeah, can
Yeah.
you give us the
The
name of
patient can do that.
I can send it to him, and it's called Can Labs. We've been using it now for over a year, and all the clinics are doing very well.
Perfect.
I personally met with the owner. He's
Oh.
very committed to patients and care, and it's he keeps the doctor safe, and they get a very high quality product, and then he just needs to work out the fee he'll make. And I have a code that they get a 10% discount. It's available online.
Okay.
There's a code there. I'll send you the code. I'm not sure. I'll send the code. I'll give the code to Bill, and then can you send it out to everyone?
I
So
can, as long as it's legal.
Legal. And of course, it's
We
legal.
gotta keep ourselves
I don't know.
out of trouble.
No. It's legal, and I mean,
Yeah,
That's a great idea. Thank
you know, the AOA has ideas also. You remember when we tried to get Dr. Tenpenny to speak for us? And
I have the code here. It's
they chased us.
DK10.
It's, what is it?
The code they can use is DK10, and the lab is Can Labs. Doggone it, Can. Oh, where is it?
No worry.
Okay,
See,
send it to me, Dave, and I'll put it out.
Yeah, I'll send it to you. I believe it's canlab.net. I got to get back in there.
We'll find it.
Yeah, we'll find it.
That's wonderful.
Most states allow patients to buy drugs from Canada.
Yeah, it's
So,
I think it's wonderful. As long as they can have it, they can really benefit. And you think that it's a good source?
it's been, I'm not an expert in the field, but we did check it. We've tested it. We've used it.
I agree with Bill,
So
though. We've been keeping it clean. Let's stay on the.
right, we try to stay under the radar, so.
Yes, sir. Thank you very
As long
much.
as we don't sometimes put it out in writing.
So just for
Right, we
Well,
know.
you guys
the
know-
doctor's serious.
You guys know that the 1997 Food and Drug Modernization Act that Clinton signed guaranteed any US citizen to be able to get any treatment from anywhere in the world.
Bravo.
The doctor is, the patient.
With a
versus
90-day
direct, the doctor's
supply,
not
by the
involved
way.
financially, it doesn't matter. The website is www.canlab.net. Canlab.net.
Can do.
And if they put in a code, they can get a 10% discount. DK10.
Okay.
It's canlab.net.
Why don't you copy the URL?
Lab.net.
Why don't you copy the URL and put it in the chat?
Sure, I can do that.
Thank
I
you.
see it, yes. Canlab.net, you're right.
And thank you again,
It's
Dr.
very good
Smith.
stuff.
Always a pleasure. And I've been in many of your classes. Like I said, you're up front.
Oh, that's so nice.
Again, this weekend, Hawkett, March 20th and 21st, starting at 8 a.m., we have our Congress of Medical Excellence 3.0. And if you'd like to join us, Dr. Smith, I'll send you the links. You're more than welcome. If you guys bring a colleague, you get $50 rebate. If you bring 7 colleagues, you get it free. It's 16 CME credits, category 1.
Wow.
What else do I need to say? We're beating the bushes here. So please help us. Dr. Block will be speaking. Dr.
Mike Beamer will help you here. Maybe David will sponsor you too. I think he's very good at sponsoring.
Well, you got
Mike Beamer will sponsor you. Ken will sponsor you. And I will look for more companies to sponsor the
Oh.
event.
You got 4 days, so make it quick.
Oh, that's wonderful.
Okay, I'll get in touch with you tomorrow.
Okay.
And-
All right,
and
guys.
put it-
I know,
Thank you, everybody. It's
Thank you.
late. Have a
I know it's
great.
late. Thank
Take
you
care,
very
everybody.
much.
Thank you, Dr.
Wonderful job.
Kathleen.
Thank
You're
you,
the
Dr.
best of the
Kathleen.
best, Dr. Kathleen. The best of the best
you.
of the best.
Thank you,
Just
Doctor.
don't tell anybody.
All right.
I'll never tell a soul.
Thank you. Thank you, Dr. Halassa, for all your help.
Thank
All
you.
right, take care.
Night, everybody.